In this video we're going to see Laplace transform. Before we begin, there is the hardest way to do it and that is the easiest way. So the easiest way is to refer this table. So every normal functions in time domain is given in the S domain, which is the Laplace transform. Now you need to add something. It's called ut minus a is equivalent to e minus as over s. So this is not given. They have given it, but given in this form. So you need to add that specific function. Okay. Now this table could be differed among the student because it's a collection of formula that's developed in different type of table in different countries. Okay, now first and foremost, this is a graph. So from this graph we can actually make the function. Now how to make the function? Now this is our amplitude now, and this is our time. Now in this time the amplitude is 5, so during 0 it's 5, so we write it as 5 ut. Now if you notice, the 5 is constant until it drops to 2. So 5 minus 2 is 3, meaning it's going negative 3. So negative 3, and this is t minus 1. Okay, it's in first second. Now it's straight until it's going up positive 3 at 3, meaning it's plus 3 t minus 3. Then it's constant till it falls down 5 at t4. So minus 5 u. Okay, sorry, you need to write the u. This ut is 0, so we don't write any time notation there, but here we see that it's at 1, 3 and 4, so we need to write it. So ut minus 4. Now this can be written in normal Laplace transform medium. Now this is in the time domain, we need to write it in the S domain. When you're writing in the S domain, it's 5 over s minus, if you remember, I asked you to write this ut minus a is equivalent to as such. So when you transform it, you will get 3e negative s over s plus 3e negative 3s over s plus minus 5e negative 4s over s. Now this particular function could be extracted into 1 over s, then you can write the balance in normal notation. Okay, now it's completed. Now we have this Laplace transform stuff, so they will give in the time domain, then we need to settle it referring to the table. So let us do one by one. So the first one, if you see here, so it's 6, the ut, if you refer here, it's 1 over s, then 5 sine 2t is this. Okay, so you would get 2s 2, then 9 cos 3t. So you can just refer the table for this, 3 square. So you would get the final answer as such. Okay, for the second part, if you complete it, it's just as I said just now. So you'd get 7 over s because you remove this, and it will become as such. Okay, now we have several other questions here which is quite different. Okay? Now this is just the same, you just refer the table, and if you solve, you'll get this as the answer. Now due to the denominator being same, you can write it as a singular answer. Now if you notice here something is different. Okay, So the easiest method you can do is, we notice that it's t minus 4. Now see here, a function with t minus a become e, this becomes here, and the function becomes f domain. Okay, now that specific function is as this function, it's a connection of two functions. Okay, now first the t minus 4 we make it as e minus 4s. Okay, now then we have t to u. Okay, now the inside we have negative 4, so it will become t plus 4, so this will become 2t plus 8. Now this should be transformed, this is in the time domain. When we transform this, we will get, so this is written as, so 2t is 2s over and 8 ut, so ut is this and t is this. Okay, you need to refer the table, so you will get the answer as such. So just now we have this, now we have this, you need to multiply both because these are a singular equation. Okay, so you will get this as the answer. Now for this, does it look same? Yeah, quite. So it's just the same, but you need to refer back the table. Now they mentioned that e negative at becomes f s plus a, so the function have s plus a. Now what we need to do is, we need to solve the cos for t first. So cos for t is equivalent to s power of 2 4 power of 2, which is s. So just now we mentioned that this is a, so a is 2, and they mentioned that fs plus a, meaning that the function should fs plus 2. Now this s should be replaced by this, so s plus 2 square plus 16. So you need to solve this first, then find the a, then input it. Now for this, this is quite simple. This is like this one, but it's quite different a bit. Okay, now t minus 2 we make it as e minus 2s because it's delayed in a function. Now this 5 cos t, now our t is 2, we just input it as 5 cos 2. Now just multiply both, 5 cos 2 e negative 2s. Okay, it's simple. Now let us see inverse Laplace. So inverse Laplace, we need to do the partial function first. So after we complete the partial function, we need to refer the table back. So now what's going to happen is, we are going to take the transform into time domain. Okay, so you're just going to do a reverse work. I am not going to refer this table anymore, so if you want, you can screenshot or take the appendix. Now this specific form, we can make it in partial function as such. Okay, after we make it in the partial fraction, we just do the cover up method. What I like to do is, now if you want to find a is equivalent to the numerator. Now we don't use this because we want to find a, we don't use the a's denominator, we use everything that's other than a's denominator. Now s plus 1, so s is equivalent to negative 1. So if you input s is negative 1 in all this s, you replace, you would get it as such. So b is same, you don't use the b, so you use the rest, you will get as thus. Now replace everything in this exact fraction, and you will get the answer if this, so this is equivalent to negative 5 1 over s plus 1, so 1 over s plus 1 is equivalent to e negative at. So if you do the inverse Laplace, you will, okay, remember to do the inverse Laplace you need to have this sort of stuff, so if you don't have, you'll lose mark. So negative 5et plus 20et minus 15e 3t and ut. So this is the answer. Need to do the partial fraction, then after you complete the partial fraction you need to do the inverse Laplace. Okay, now in this case the fraction is quite okay. In some cases the fraction could be long division, the fraction could be anything that's not suitable. Okay, so beware. Now this, what about this? Okay, here they have made it as I. Now if you see here, it's F. So if you replace the F as I, you will get, and here they have a big F, small f. Then if you notice here, small I, big I, so it's just the same. They just use the different notation because they are talking about current, not just a function. Okay, now referring to the table, the table just I showed, you will get, okay, we are now writing in the I domain, but if you want to write it in the S domain, F domain function, it's not a problem. So it's just this but written in a different format. Okay, do not to be confused. Now we write this expression in the expanded form. So it is now is in the big form, and this one, if you do the transform, you will get as this. Okay, now you just need to simplify this. So when you are simplifying this, you would be getting, you need to input this. Yeah, if I0 it's 4, it's I0 it's 2, so you need to be careful with that. So this mathematic is something that you need to practice aside from watching and understanding it. And also you need to be careful with your calculator and the number that you are writing. Sometimes the number that you write could confuse your own mathematics, so beware. Now I may skip some step to save the time from me writing this whole equation. So you, if you are able, or if you are available, and if you have the time, please do it by your own. Now when we want to make sure that the, okay, in this part of case we have moved it, it's like we have this and we have is, then this member here has the denominator. Now what we should do is we should multiply the numerator with the denominator, but the denominator stays the same. The denominator should not remove from its place. Okay, so beware of this crucial step. Now the rest is, after it's being simplified, it would become as such. Now this is back in the partial fraction as just what we did. Okay, now doing this back, we will get the partial fraction using the cover up method is as such. So if we rewrite, our b is 0, so we no need to bother about b, so we rewrite the balance stuff that we have and this is the answer that we get. So if we make it in the frequency domain back, or the current in our word, we will get the answer as thus. Okay, now the last part is for the circuit. So you need to understand certain stuff in the circuit, and you need to understand basic circuit law, like current is same in series. Okay, current is same in series, voltage is same in parallel. So you need to know that certain stuff in order for you to understand this. So I said that capacitor is 1 over s, then inductor is s, resistor is just the value. Now we have the certain values here, so we make sure we already change the value. So 1 over 0.2 s is equivalent to 5 over s, then 2 Henry is equivalent to 2s, 2 ohm is equivalent to 2. Then we have our 2i, which is equivalent to this I. We won't bother because it's coming from the Vs as well. Now the question asks us to do VO over Vs. So VO is here and Vs is here. So we notice that Vs is coming here, then it's having another current here, so the current is traveling here. Okay, so the node that we need to be careful with is the node V1. Now what happens in the node V1? So a current coming here, a current coming here, and a current going out. So this current is named as I1 and this current is named as 2I1. So the total current that's traveling in this way is 3I1. Okay, now if you remember what I said, current is same in series. Now voltage is same in parallel, meaning that the voltage of Vs is not same as this. Okay, so don't do the stupid stuff. Current is same in series, meaning that the current here is the same current here, meaning if current 3i is traveling here, the same current is also traveling here, meaning VO is just 3i1 times by 2 ohm, which is equivalent to 6i1. Now we know that VO is 6i1. Using this, we just can make it that I1 is equivalent to VO by 6. Okay, we just replace the mathematical equation there. Right, now we will put this aside. Now we also know that V1 is equivalent to, okay, V1 is equivalent to the voltage of these two resistance times by the current, right? So the voltage here is the same as this impedance or the total resistance here times by the current. So V1 is equivalent to 3I1, which is the current traveling in this direction, times by 2s plus 2, which is equivalent to, we just now mentioned that I1 is VO6, so 3I1 meaning 3 times VO over 6, which is equivalent to VO over 2. Now 3I1 is VO over 2 times by 2s plus 2. If you simplify it, we will get VO as plus 1. This is our V1. Alright, now we know that our I1 is equivalent to V1. Okay, so our Vs is here, V1 is here, so we know that our I1 is equivalent to Vs minus V1 over 0.2f, which is in our domain is 5 per s. So Vs minus V1 is Zc, or named as 5 over s. Now do we know Vs? No, but we know that I1 is V0 over 6, which is equal to Vs minus V1 is Vos plus 1 over 5 per s. Now if we write it in the correct form, we would obtain as thus. Okay, so we don't need to have that. Now we just move the numbers here, so this comes here, this comes here. It would make the equation easier, as we could see as such. Okay, now if we solve this equation, we would get as what I am writing here. You may recheck your working soon. Okay, and then we move our Vs, because Vs we move it here, Vo we keep it here. So what we would get is, so you need to be careful with your negative and positive there, so beware again. So this is our Vo. Now Vs is 6s square plus 6s plus 5Vo over 6s. Now Vs over Vo is 6s square plus 6s plus 5 over 6s. The question asks for Vo over Vs. So Vo over Vs is just the inversion of this. Okay, so you need your basic circuit skills, and you need to know what to do. Okay, that's all. Thank you.